Okay, let's give you guys some more practice. So here, find the derivative of this. Find dy by dx of this. Okay, so press pause and have a go. Okay, so to do this here, imagine this as being in one bubble here, and this is another bubble here. So visualize this thing here as this. Okay, and then take the natural log of both sides. That would then so log this side and then log this side. So that would then give you this. Okay, and then whenever you log a over b, that equals a log of a take away log of b, So that will then give you this. Okay, and then hang on, and then and then when you are here, it's important that you need to imagine that this here is in one block here. So it's minus the whole thing. So this is like one block. So at the moment you've got this, but it's important that you visualize it as this. Okay, so insert the brackets here. Okay, so that will then give you this, and then this minus here is on the outside here. The rest you've got to imagine is you've got to imagine it as being like this. You've got one bubble multiplying with another bubble, so that becomes log of x plus log of this thing here. Okay, but remember that the minus is on the outside here. So later on it's going to be minus log of x and then minus log of this whole thing here. Bear that in mind because it's important that you insert the brackets here. Okay, and then anyway, we are currently here at the moment. So now so this then gives us negative log of x, and then this then gives us negative this thing here. Okay, so now use implicit differentiation. So that will then differentiate this. That will then give you this. And then differentiate this here will be 1 over this thing, and then you've got to times the derivative of this bubble here, which is just 2. That's this 2 here. And then come to differentiate this, it will just be 1 over x, and then differentiate this here. So differentiate this will give you 1 over this bubble here. That's this bubble here. But then you've got to times the derivative of the bubble itself. So you've got to times with cos 3x, okay, and then this is stuck inside another bubble here. So then you've got to times the derivative of the inner bubble itself. So that will give you a 3 there. Okay, so this bit here is you using the chain rule here, and then it's a matter of simplifying it. So this gets multiplied to the top, giving you this. This here gets multiplied to the top, and so on. And then you've now got 3 fractions here. 1, 2, 3. So merge them together. So for this fraction here, times top and bottom by this and this. Okay, and then for this middle one, times top and bottom by this and this. And then for this one here, times top and bottom by this and this, meaning x bracket 2x plus 4 and then times the bottom by the same thing. So that will then give you this, and then all the denominators will then be the same, and then you can merge all 3 together, giving you this fraction here. Now you want to somehow isolate this this dy by dx. So times both sides by y. Don't forget, initially our y was this right from the start. This was our y. Okay, so we are currently here at the moment. So when you are here, times both sides by y. That will then give you this whole thing here. So this is our y here, and then this is exactly the same as this. So now it's just a matter of top times top, bottom times bottom. Remember that when you get top times top, it's this times and then bracket the whole thing here. Okay, so you have to do this times this times this, and this times this. But it's easier just to notice that this is exactly the same as this. so it gets cancelled out. You might be able to simplify it even further, but I'm just going to leave it as it is. And then bottom times bottom here, this times with this, that will give you x squared, and then exact same thing times exact same thing, so that will give you sine squared 3 of x. Okay. Anyway, dy by dx will be this. So now get yourself a graph plotter, plot the original graph, and then plot dy by dx here, and it will give you something like this. Okay, so you can use this to double check your answer. So so the red line represents our original y. The blue line represents a derivative. So looking at the red line here, you can see start anywhere. Let's just start here. You can see that it's negative. It's going downhill. It's going downhill. It's going downhill. And looking at the blue line, it's in the negative. It's in the negative. It's in the negative. And right at this point, somewhere here, looking at the red line, the derivative here is 0. Now look at the blue line. The derivative here is actually 0. Okay, and then look at this bit here. It's going uphill. It's going uphill, 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 uphill. And looking at the blue line, it is in the positive gradient here. Okay, let's choose another random point. Let's say around here. You can see here it's going downhill, 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 downhill. And looking at the blue line, it is downhill, downhill, downhill. Okay, and then looking back at the red line, the gradient here is 0. Looking at the blue line, the gradient here is actually 0. Okay, and then here it's going uphill, uphill, uphill. The blue line, it is actually in the positive realm, so it correlates with. So now let's look at this weird point here. It's going uphill, 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 uphill. So here the blue line is in the positive. Okay, and somewhere around here, the gradient is 0. Looking at the blue line, the gradient is 0. Okay, let's look at this weird thing here. It's always going downhill here. Negative gradient, negative gradient, negative gradient, negative gradient. You see, if you look at this line here, there is no point where the gradient is 0. Well, guessing that there's no point on here where the gradient is 0. It seems as if it's going downhill all the time. And then looking at the blue line, you can see that there is no point on that line where the gradient is 0. It's always going downhill, meaning that the blue line is always in the negative realm. Well, if the blue line is always in the negative realm, then the red line must always be going downhill. Okay, so it seems as the graph here supports that our derivative here is correct. Okay,